A software development team building web applications needs tooling that covers the entire development cycle without requiring context switches between 7 different applications. They need an AI-augmented terminal for running commands with contextual suggestions and error explanations, a framework for embedding AI Copilot features directly in their internal tools, a browser automation library for writing end-to-end tests and scraping data from interfaces their applications interact with, a monitoring system for tracking application performance and infrastructure health, and a knowledge base for storing architecture decisions, runbooks, and code patterns the team references repeatedly. Without these layers working together, the terminal, the tooling, the tests, the dashboard, and the documentation each operate in isolation, and the team loses time switching between them. With a connected development platform built from these 5 repositories, each layer feeds the next, and the team operates with full visibility from the terminal command to the production metric. Intelligent Terminal provides the command execution layer. It is an AI-augmented terminal that interprets commands with contextual awareness, suggests corrections for failed commands, and explains error messages in plain language. The development team uses it as the primary interface for running builds, managing containers, executing test suites, and interacting with infrastructure, with the AI layer reducing the time spent deciphering cryptic error output and searching for the right command flags. CopilotKit provides the in-app AI assistance layer. It is a framework for adding AI Copilot features to React applications, including contextual chat panels, action suggestion interfaces, and AI-driven form fill and code generation. The team's internal tools, the deployment dashboard, the test reporting UI, and the incident response interface all embed CopilotKit panels so engineers can ask questions about the current state of the application or request automated actions without leaving the tool. Puppeteer provides the browser automation layer. The team uses Puppeteer to write end-to-end tests for the web applications they build, to automate browser interactions with third-party interfaces the applications depend on, and to generate screenshots for visual regression testing. Puppeteer runs in headless mode in CI and in headed mode locally for debugging. Grafana provides the observability layer. Application performance metrics, infrastructure utilization, test pass rates, and deployment frequency are all displayed in Grafana dashboards that the team monitors during development and on-call rotations. Onyx provides the team knowledge base. Architecture decisions, debugging playbooks, API integration notes, and code patterns are stored as searchable Onyx entries linked by topic and project. When an engineer needs to understand why a particular design decision was made or how to debug a recurring error, the answer is in Onyx rather than in a Slack search. Tracing a feature deployment from the first terminal command to a confirmed production metric shows the data flow through all 5 repositories and explains how each layer contributes to the development cycle. The flow starts when an engineer opens Intelligent Terminal to run the build and deploy sequence for a new feature. The engineer types the build command in Intelligent Terminal. The terminal runs the command. When it fails due to a missing environment variable, the AI layer explains the error, identifies which variable is missing from the configuration, and suggests the corrected command. The engineer confirms and runs the corrected version. This feedback loop, command, error, AI explanation, corrected command, happens in a single terminal session without a browser search or a Stack Overflow visit. Once the build succeeds, the engineer opens the deployment dashboard built with CopilotKit. The CopilotKit panel on the right side of the dashboard allows the engineer to ask about the current deployment state in natural language, which version is running in each environment, what the last deployment changed, and whether any health checks are currently failing. CopilotKit retrieves this context from the dashboard's data sources and responds directly in the panel. The interfaces between CopilotKit and the dashboard are the application state the framework reads and the actions it can trigger, which are defined in the CopilotKit action configuration. After deployment, Puppeteer runs the end-to-end test suite against the staging environment. The test results, pass counts, failure screenshots, and test duration are written to the team's metrics store and displayed in Grafana on the test quality dashboard. Grafana's deployment annotation marks the timestamp when the new version was deployed, so the team can correlate any metric changes with the deployment event. The engineer writes a brief note in Onyx documenting the environment variable, that caused the build failure, the correct configuration format, and a link to the relevant infrastructure documentation. The note is tagged with the project identifier and the error type, so the next engineer who encounters the same issue finds the solution in under a minute. The build order starts with Onyx, since the team knowledge base needs to be populated before it can answer questions about existing decisions and debugging patterns. Deploy Onyx using its server mode and configure the initial folder structure, one folder per active project and one shared folder for cross-cutting runbooks and API patterns. Import the team's existing documentation, README files, architecture notes, past postmortems, by creating entries through the REST API. Verify that a natural language search returns the correct document for 3 representative queries before connecting Onyx to the rest of the platform. Set up Grafana next. Deploy it using its Docker container and configure the initial data source for the application metrics endpoint the team's services expose. Create 3 dashboards, one for application latency and error rates, one for infrastructure utilization, and one for CI metrics, including test pass rates and deployment frequency. Add a deployment annotation API call to the team's deployment script so Grafana marks each release on the timeline automatically. Verify that a simulated spike in error rate triggers the configured alert before the alert rules are considered production-ready. Configure Puppeteer. Install it with a Playwright-compatible browser in the CI environment and write 3 baseline end-to-end tests, one that verifies the application's primary user flow, one that checks a form submission, and one that takes a screenshot of the dashboard for visual regression comparison. Run the tests against the staging environment and confirm they pass before adding them to the CI pipeline. The interfaces between Puppeteer and the CI system are the test result exit code and the screenshot artifacts uploaded after each run. Security in this stack requires that the Onyx API token used by the CopilotKit backend be loaded from an environment variable and never logged. Grafana's authentication must require login before displaying any production metrics. Anonymous access must be disabled. Puppeteer test scripts must not embed any real credentials. They must read test account credentials from environment variables injected by the CI system. Failure handling in the Puppeteer test suite retrieves a failing test once before marking it as a failure, since browser timing issues cause intermittent failures that are not real regressions. After one retry, a persistent failure writes a screenshot to the artifact store as a fallback diagnostic so the engineer can inspect the visual state at the moment of failure without rerunning the test. Deploy Intelligent Terminal on each developer's workstation using its installation script. Configure CopilotKit as part of the internal tool React build and connect it to the deployment dashboard's data sources. The production deployment is complete when a developer can run a build command in Intelligent Terminal, check deployment status through the CopilotKit panel, review test results in Grafana, and find the relevant runbook in Onyx without leaving their primary tools. The documented configuration of each repository defines the development platform's coverage and operational constraints. Intelligent Terminal is MIT licensed. Its documentation covers the installation script, the shell integration configuration, the AI backend connection for command suggestions and error explanation, the command history context window size, and the supported shell environments. The project notes that it works with any terminal emulator and that the AI suggestions use only the local command history and error output as context. CopilotKit is MIT licensed. Its documentation covers the React provider configuration, the action definition format for registering AI callable functions, the context provider API for supplying application state to the AI layer, the chat UI components for embedding a Copilot panel in any React layout, and the streaming response API for progressive output. The project notes that CopilotKit is model agnostic and that the LLM backend is configured at the provider level. Puppeteer is Apache 2.0 licensed. Its documentation covers the browser launch configuration for headless and headed modes, the page navigation and element interaction API, the screenshot and PDF capture functions, the network interception API for mocking external dependencies in tests, and the browser context configuration for isolating test sessions. The project notes that Puppeteer bundles a compatible Chromium version by default, and that an existing Chrome installation can be used instead. Grafana is AGPL licensed. Its documentation covers the data source plugin configuration, the dashboard JSON model for version-controlled dashboard definitions, the alert rule format with threshold and condition expressions, the annotation API for marking events on time series panels, and the notification channel configuration for routing alerts. Onyx is MIT licensed. Its documentation covers the REST API for creating and searching notes, the tag and backlink system, the folder configuration for organizing notes by project, and the webhook format for receiving entries from external pipeline systems. The project runs as a local desktop application or a self-hosted server. The fastest path to a working development platform is deploying Onyx and importing 3 existing runbooks. With searchable documentation in place, Grafana and CopilotKit have context to surface during incidents. Which recurring error in your current codebase would you most want Intelligent Terminal to explain automatically?